So I've assumed his role.
All right. Congratulations.
Thanks.
Hello. Can everyone hear me? Hi. So I know we're just a little bit late getting started, but the team did an outstanding job turning the room around. So I want to thank them, thank all the staff for that. And we're going to get started in, we'll get started right now. So we are not further delayed. And I'm going to use this mic because I don't feel like being up on the stage. I'm not going to sing or dance or anything. So I figured I'd just be down here. My name is David Albright. I'm with EPA Region 9. I'm the manager of the Groundwater Protection Section. And this session today is going to be a panel discussion. Although I'm the only one in the room, we've got 3 remote presenters. So I hope we can pull it off. This is federal and state authorities and programs for groundwater protection. So this is an issue that came up at one of the prior RTALK meetings. We were asked about, EPA was asked about how groundwater is protected, and our response was, well, it's kind of complicated. There's a lot of different parties who are involved. There's a lot of different authorities involved. So we agreed to have a panel, and I've got a couple of folks from states on, and then I have a colleague of mine with EPA. And so we're going to start. I'm going to introduce the remote presenters now. And then they'll start their presentation, and hopefully you'll be able to hear them. So I have Annalisa Kihara, who's with the California State Water Board, and she's going to go first and talk about protecting California's groundwater. And then I have Wayne Harrison, who's with the Arizona Department of Environmental Quality. And then my colleague Sarah Samples, who's with the NEPA Review Branch in the Tribal Intergovernmental and Policy. You may know them as the TIP division. And then I'm going to go last. So we've got a lot to cram into this time frame, but hopefully we can present a lot of good information and then have a little bit of time at the end for questions. So I'm going to turn it over to Annalisa Kihara.
Thanks, David, and hopefully you guys in the room can hear me okay. Apologies that I couldn't be there in person, but really appreciate the opportunity to present to the group virtually. As David mentioned, I'll be providing an overview of our programs that we have at the State Water Board protecting California's groundwater. Bruce, would you be able to pan to the next slide or let me know if I need to?
Yeah, Annalisa, I have quicker, but it doesn't seem to be working.
Oh, there we go. Okay, thank you. So I'm going to start big picture with the State Water Board. In California, we have our State Water Board and our 9 regional water quality control boards. Collectively, we're called the water boards, and our regional boards are separated geographically, but also by watershed. So collectively, our water boards have a vision where we see a sustainable California made possible by clean water and water availability for both human uses and environmental resource protection. Next slide, please. Yeah, and it's totally fine if you want to keep it on this so that it's easy to go to the next slide, whatever works. Okay, so what I'll do is I'll start off with one of our larger programs. It's our Groundwater Ambient Monitoring and Assessment Program, also called GAMMA. This program was created in 2000 due to concerns over groundwater quality and emerging contaminants. And then 2 years later, we expanded the program following passage of the Groundwater Quality Monitoring Act, also known as AB 599. And so for our GAMMA program, we have a handful of goals, some being to improve statewide comprehensive groundwater monitoring. Another is to establish ambient groundwater quality on a basin-wide scale. So just really to understand what baseline is in California for groundwater quality, to continue periodic groundwater sampling and groundwater quality studies so that we can understand changes over time. And then last but not least, to centralize the availability of groundwater information to the public and decision makers. So really transparency is something that's very important to us at the water boards as well. Next slide, please. So I won't spend too much time on this slide, but really the key message is that as we implement our GAMMA program, we collaborate with a lot of other entities, including but not limited to Lawrence Livermore National Laboratory and the University of California, Davis. And we have a lot of projects that we implement, but what I'll do is the next 3 slides, I'll highlight 3 of them that we thought as we put the slide deck together would be of interest to the audience today. So next slide. I think there's one right before this. There we go. GAMMA Priority Basin. So that's one of our projects that we implement in collaboration with the United States Geological Survey. USGS is the technical lead to assess both deep and shallow groundwater resources through a statistically unbiased grid sampling network. And so the main goals of this Priority Basin project is to provide an assessment of current groundwater quality, including those factors that affect groundwater quality, to detect changes over time, and then also to share the publicly collected data to the public. Next. Actually, before you can keep it on this slide, but I did want to just share for the GAMMA Priority Basin project. We're actually on the 3rd iteration of that project. And this all started in 2004, where we originally focused on assessing groundwater used for public drinking water supplies. And then we shifted in 2012 to do an assessment of our shallow aquifers to understand those water supplies for domestic wells, which are much more shallow. And then starting in 2024, in terms of what's to come, what we'll be doing is utilizing the decades of data that we've collected to apply more interpretation and analyses, especially knowing that there's a lot of questions that are coming up in California regarding climate change, including recharge, where we should be doing recharge, where contamination could be mobilized if we implement recharge, and then also regarding seawater intrusion. So just a little bit more information on that priority project. Okay, moving on to this slide that we have here, GAMMA GIS. Our groundwater information system really the goal of this system is to standardize water quality information into one centralized system. And so what we do is we collect data from various internal as well as external sources, and we take all of that data and we standardize it to provide users accessing our site, querying options across various data sets. And so those data sets include drinking water well data that's been collected, contaminated site well data, the USGS sampled well data, as I had mentioned in a previous slide, any local agency collected water well sample data, and then as well as non-governmental organization collected well data. So this is really getting at recognizing there's always a lot of parallel efforts in California when it comes to monitoring, and can we bring that all into one place and create visualizations where you could get a full story. Next slide, please. And the last project that I'll touch on our larger GAMMA program is an aquifer risk map. This map is a part of the larger SAFER program, and SAFER stands for the Safe and Affordable Funding for Equity and Resilience. And that program was designed to ensure that Californians who currently lack safe and affordable drinking water receive it as quickly as possible. So unlike public water systems in California, domestic wells and state small water systems are not regulated by the state. And so we often don't have direct water quality samples available. So what we do with this map is we use nearby data to estimate risk of assessing groundwater that does not meet primary drinking water standards. So really it's just an assessment of risk. So this aquifer risk map is used by the water boards to prioritize areas for funding as well as outreach. And the map can also be used as a screening tool by the public to identify areas where domestic wells or state small water systems may have water quality issues and could need some technical support. Next slide, please. And so I'll be moving on to a different monitoring program for oil and gas activities that we have at the water boards. Some background on this is that California Senate Bill 4 was passed in 2013, and it required the state water board to implement a regional oil and gas groundwater monitoring program. And the overall goal of this program is to assess the potential impacts to groundwater from oil and gas related activities, such as well stimulation, also known as hydraulic fracturing, underground injection projects, as well as produced water ponds. And so in this program, a lot of the information we've collected and publications resulting from that can be found on our oil and gas website, and I've included that link on this slide. Next slide, please. So David will likely cover a little bit more about this, but the California Geologic Energy Management Division, also known as CalGEM here in California, received primacy from the US EPA to regulate wells used to inject fluids that are associated with oil and natural gas production operations in the subsurface. And so while they have primacy, we are currently working with CalGEM through an MOU signed in 2018 to review all underground injection projects in the state to ensure the protection of water resources. And so the status of our project reviews are available to the public on our GeoTracker information site, and I've also included that link on this slide. Next slide, please. Okay. Carbon capture sequestration. So this is a new type of injection project that we've recently been involved with at the water boards. And it's an emerging strategy intended to reduce greenhouse gas emissions and to mitigate climate change in California. And so while US EPA is the permitting agency, the water boards are part of a multi-agency effort to develop a process for permitting these wells in California and to ensure that we're protecting beneficial use aquifers. So had to add a plug for this. Next slide, please. And so I'm going to be pivoting a little bit to a couple of the other programs that I have at the water boards, one being our groundwater discharge permitting program. And so in California, we permit discharges to land through authorities given to us in the California Code of Regulations. We call this our Waste Discharge Requirements Program. And so really the idea of this program, knowing that there has to be discharges to land, but we want to do it in a way that's protective of water quality and ensure that they are nothing like the image that I have on this slide. So in this program, our authority is broad, but typical discharge types that we permit and we permit stringently include domestic or municipal wastewater, food processing related wastewater, and industrial wastewater. Next slide, please. Okay, and so kind of on the other end of it, we do implement site cleanup programs at the water boards. There are two of them in particular that I have under my umbrella. One is our petroleum underground storage tank program. And so this program concentrates on cleanup at specifically historical or existing gasoline stations or other areas that had leaking petroleum underground tanks. And then on the converse, or I guess as a catch-all, we have our site cleanup program. And so that program covers all other constituents, especially those that are hazardous and will not bioattenuate. So a lot of the harder sites that we deal with are within our site cleanup program, including chlorinated solvents as well. And so I just wanted to put a plug to the link that we have on the slide. We have a site cleanup program story map where our team put together a really great story map about both programs, how they overlap, how we're learning from one another, and then our vision of implementing these programs in the future. Next slide, please. Okay, so I started this presentation with an overview of the water boards and our vision, and I thought it would be great to end with sharing a bit about our racial equity, diversity, and inclusion efforts at the water boards. So we have a water board's racial equity vision where we envision a California where race no longer predicts the access to or quality of water resources, where our water board's employees at all organizational levels reflect the racial and ethnic diversity of California, and where a racial equity lens is consistently applied to water boards' decision-making processes. And so along with this vision, we're also implementing a racial equity resolution and an action plan, and kind of working towards that last bullet of applying that racial equity lens to the programs that I have covered in the last slides through either the addition of data sets like census data or through identifying additional interested parties or community members or groups for input on our efforts. So just wanted to share that and end my presentation with that. And I do have one last slide. And this slide has some resources and ways to connect and stay updated with our water board's efforts. And with that, I will maybe pass it back to David or pass the mic to Wayne.
Thank you, Annalisa, for that presentation. And if I could, we're going to ask folks to hold any questions till the end of all the presentations. So I think we're going to now queue up the next presentation, which is Wayne Harrison's. And we'll get Wayne on the line.
Yeah, hello, everyone. Delighted to be here today to share some thoughts with you, and hopefully you can hear me okay.
We can hear you.
Great. Yeah, I was asked to present on what the state of Arizona government is doing for groundwater protection, and let's advance to the next slide, please. Perhaps the most useful thing you'll get out of my presentation today is a link to other resources. At the end of the slide deck, there's a link to resources, and then there's a couple other links within the presentation itself. Arizona manages groundwater in two agencies that have authority for administering programs. And the two agencies are the Arizona Department of Water Resources and the Arizona Department of Environmental Quality that I represent today. ADWR manages the quantity of groundwater in Arizona, and ADQ has jurisdiction over the quality of that water. And the two programs I want to highlight today on behalf of ADQ are the Ambient Groundwater Monitoring Program, that is a statewide water quality monitoring of the groundwater basins in Arizona, and a prevention program, a permitting program called the Aquifer Protection Permit Program. It's where our permitting, inspection, compliance assistance, and enforcement are happening to protect groundwater. And I just wanted to point out at the outset, although it's a shared resource and we understand the sacredness of water to the tribal cultures, that Arizona Department of Environmental Quality doesn't have jurisdiction over tribal lands. We recognize the sovereignty of these tribal lands and governments of the 22 federally recognized tribes in Arizona. Next slide, please. You can see a map on the right of some of the coverage areas over the past 30 years that have been sampled. Each of the basins, the dark blue ones have individual basin reports that have been completed. And then there's a variety of other statuses that you can see there in different colors, reports that are in progress, or places where there's little or no sampling. And you can see that the tribal lands are outlined in a dark gray there, and areas with no sampling in kind of a light gray. So there are large areas of the state where there just isn't data or very much of it. We know that ongoing groundwater monitoring is really essential to understand aquifer quality and the health. In Arizona's statutes, the legislature has defined all Arizona groundwater as drinking water, so therefore it needs to be protected. And we've collected samples through this program in 39 basins. And we've published reports on 33 of those basins, and that's an important takeaway from this presentation. Is there's a link at the bottom to all the basin reports and fact sheets that go along with those. If you're interested in the quality of water in your basin or adjacent to your tribal land that might be reported in these basins, you can get a feel for what has been done within the state jurisdiction on adjacent areas, and it'll give you a feel for what the groundwater quality is. Next slide, please. There's the importance of groundwater testing really lies in the fact that 300,000 Arizonans utilize private wells for their drinking water needs, and those are unregulated by the state. We don't regulate the private wells. And so these basin studies help inform for the public what the quality in those basins are. And a picture on the right that shows a bunch of dots on the state of Arizona shows you the well coverage and the distribution throughout the state of Arizona. And a couple of pictures of covers of the 20-year report and a basin report and a fact sheet that is representative of the type of information that we have available on the link that I presented. Next slide, please. I just wanted to touch quickly on some results from the 20-year report, and this is covers the time span of 1995 to 2015. There's really the big five constituents, we call them, that exceeded primary MCLs in a good percentage of the sites. Arsenic, fluoride, nitrate, gross alpha, and uranium are two radionuclides. So when you're thinking about the health of your aquifers, those are probably the top five things you're going to want to sample for on tribal lands. just because it's more predominant across Arizona. We have a wealth of varying geography in Arizona, and each one of these basins has a different geochemical character that the natural rock formations impart on the quality of the groundwater. And that's a very important constituent that makes up the quality of the water that you'll have in your wells. Some of that is much of that is natural, but some of it could also be man-caused. And the map you see to the right shows different color characteristics representing how many percent of the sites within that basin exceeded primary MCLs. Please advance to the next slide. I want to shift into an overview of the Aquifer Protection Permit Program. It was authorized by the legislature in 1986. It requires permits for all discharges to groundwater that would be defined as any addition of a pollutant with a reasonable probability of reaching an aquifer, either directly via land, surface, or vadose. And most the types of facilities that fall under this typically are sewage treatment facilities, industrial operations, mining activities. You can see there's a distribution. Most of the permits are issued to wastewater treatment plants and industrial facilities, with another smaller percentage associated with mining operations. You can see the distribution of permits that are active right now across the state on that map. And the more densely covered areas represent areas of higher population concentration, with, probably in the rural areas, it's more smaller water systems, sewer systems, or mines. And this program enforces best available demonstrated control technologies and requires them, we call that bad cat, to reduce our discharges as a result of those permits. And if you could advance to the next slide, please. There's a couple of key program elements. Those bad cat demonstrations are really important for these permits because they help define how we're going to minimize the discharge that occur from these permits and help us comply with water quality standards. And those water quality standards need to be demonstrated and proved at a point of compliance well that are monitored. These facilities also need to address the technical and financial capability that they offer to protect groundwater and operate their sites. And they also provide financial assurance for closure. So if you could please advance to the next slide. This is our contact information. My email is there. I want to introduce Len Drago, who's there with you participating in the audience today. Thank you, Len. Len is our EDQ tribal liaison. He's there available to answer any additional questions you might have after this session. There's a link to the tribal website and another link to the ADQ groundwater basin reports and fact sheets. Thank you very much, and I'll turn it over to David and Sarah.
Thanks very much, Wayne. Appreciate that. Lots of good information, and Len is there if people have Arizona-related questions. So we're going to move to the next presentation, and that will be by Sarah Samples, who's with EPA's TIP division.
I can go ahead and introduce myself in a little more detail as you're pulling up the. Again, my name's Sarah Samples. I'm a NEPA reviewer in our environmental review branch housed under the TIP division. And today I'm going to be presenting on the National Environmental Policy Act, Resource Conservation and Recovery Act, and the Toxic Substances Control Act, and how we use these policies and laws to ensure groundwater protection in our projects. Unlike Annalisa and Wayne, these policies and laws don't actually have specific regulatory authority for groundwater protection, but they still consider groundwater impacts through the review or permitting process. So I'll spend most of the presentation on the National Environmental Policy Act, or what I'm going to call NEPA from now on. And then we'll briefly discuss the similarities in the Resource Conservation and Recovery Act, or RCRA, and the Toxic Substances Control Act, or TSCA. So you can go to the next slide. Oh, I think it's a different PowerPoint than I remember. So you can skip past this slide to the next one. So to cover a few basics, the NEPA was one of the first laws ever written to establish a broad national framework for protecting our environment. The passage of NEPA actually jump-started the environmental movement of the 1970s, which is pretty cool. And other major laws followed, like the Water Act or the Clean Air Act. The policy is to assure that all branches of government, federal government, give proper consideration to the environment prior to undertaking any major federal action that significantly affects the environment. So major federal actions can be really a wide variety of things and cover a lot of different sectors. So in my office, we separate those into mining, transportation, energy, natural resource management, military, and tribal projects. NEPA analyses must cover almost all in federal environmental laws, and RCRA and TSCA are the exceptions that don't fall under NEPA. So if you could click. Thank you. You can picture NEPA as an umbrella law because it's under most environmental laws, either administered by the EPA or other federal agencies. It also includes executive orders and tribal trust responsibilities. So this means when I'm reviewing a project for my branch, I look at impacts to threatened and endangered species under the Endangered Species Act, or water quality under the Clean Water Act, environmental justice under both executive orders, and so on and so forth. So at its heart, NEPA is a planning process that's designed to evaluate environmental impacts and allow for informed decision-making for federal agencies. So let's move on and take a look at the three different types of NEPA analysis. Go to the next slide. Most agencies have a list of projects that are what's called categorically excluded, or a Cat X. A Cat X doesn't require in-depth NEPA analysis because these are known activities that would not significantly impact the environment. And each agency has its own method and process to determine and document categorical exclusions. We don't typically review published Cat X's in my office. But the next type of analysis is what's called an environmental assessment. And if time permits in my office, we do review these. The impacts in an EA are either known to not be significant, or the EAs are developed to determine if there is a potential for significant impacts and the need for what's called an environmental impact statement, or an EIS. So an EIS is prepared when impacts are expected to be significant. The regulatory requirements for an EIS are much more detailed and rigorous than the requirements for an EA. And at the end of the EIS process, a record of decision is required to discuss the agency's decision, describe the alternatives that they looked at in the process, and discuss the agency's plans for mitigation and monitoring. So next slide. So if EPA isn't the lead agency, what's our role?
Sarah? If you're speaking, we can't hear you.
It looks like Sarah's camera is frozen up a bit, so there may be some lag.
Required under Section 309 of the Clean Air Agreements, including technical analyses like groundwater modeling or air quality impacts analysis. If we have major objections to the environmental impacts or the information provided in the EIS, our goal is to work really closely with the lead agency to resolve these issues. And just a heads up that all EPA comment letters are publicly available. So if you are interested in seeing what we've commented on and projects in the past, we do have a website where those letters are posted. So you can go to the next slide. So the main point of today's panel is to discuss groundwater protections. And as I mentioned at the beginning, there's no regulatory hook for these protections under NEPA. EPA's only hook is what David, our next presenter, will be discussing. That doesn't mean that we aren't looking for ways to protect the groundwater through a NEPA analysis. So with that, I wanted to cover in general how we look at potential impacts to groundwater, which also broadly apply to the other resources that might be affected. So as part of the NEPA process, one of the first things that we do is get baseline studies. So this determines the affected environment or what exists within the project area in its current state. Next, depending on the type of project and baseline studies, groundwater modeling might be needed. The picture you see in the slide is a groundwater modeling figure from a gold mine in central Nevada. So EPA reviews all groundwater modeling for mines, and for other projects in our office that may affect groundwater as well, we take the same approach. So once we review the modeling and the potential impacts, we can look at what can be done in terms of avoidance or minimization. And then we also look at, well, what would the mitigation measures be? So this is a part where working together with the lead agency and other parties that are involved is really important. For mines in particular, there are concerns about groundwater usage or water quantity and water quality. Most of the mines that we work with in my office are in Nevada. So the Nevada Division of Environmental Protection does issue water pollution control permits to protect water quality. This makes sure that the pollutants in the groundwater are not exceeding regulated amounts. And in terms of quantity, there aren't any laws that regulate or prohibit the dewatering of groundwater and mining. EPA attempts to ask for mitigation in the event that seeps, springs, or streams or other bodies of water are impacted by mine dewatering. And the length can really vary. Some can be really short term and others can last hundreds of years. So for the mine in the picture, it actually is proposing mitigation to supplement water to an important creek for about 500. So with that, the basic outline of NEPA reviewers, or the basic approach that NEPA reviewers in my office take to look at groundwater is to determine the site characterization and the baseline data collection, what's the affected environment, and then to do modeling and evaluate to determine what are the water quality and water quantity. And then at that point, we go into avoidance or minimization measures, as well as providing monitoring plan recommendations or appropriate mitigation. So you can go to the next slide. I'm going to touch on this briefly because I have a sense that most people understand what tribal involvement is in NEPA, but there are several different ways that tribes are involved. And apologies, there is an error on the slide. So it jumps from 3 to 4. But I just want to touch on these briefly. As part of early coordination, we want to invite the tribes if their involvement is reasonably foreseeable. I say we, meaning the lead agency. Then as part of the scoping process, the lead agency is required to invite the participation of affected. There are EIS conflicts between the proposed action and the objectives of tribal land use plans or policies or controls. And then after preparing a draft EIS and before preparing a final EIS, the lead federal agency must request the comments of Indian tribes when the effects may be on a reservation. For projects that aren't on a reservation, EPA still asks to include any tribal concerns within the NEPA documentation. And we always ask, what were the actions taken to address these concerns? Then finally, the last two is that agencies must provide public notice of NEPA related and important documents. And then finally, tribes can also serve in a cooperating agency capacity, which is a more formal role within a NEPA process. And there are additional regulations that we look at that apply to tribes in the NEPA process. But for the sake of time, I'm just going to skip those and let's go to the next slide. So these two laws don't necessarily look at groundwater protection from a regulatory standpoint, but they're really similar to the NEPA process. So RCRA and TSCA do not undergo NEPA, but they're considered what's functionally equivalent. So they go through many of the same steps that I outlined for you today. So RCRA gives EPA the authority to control hazardous waste from cradle to grave. So this is generation, transportation, treatment, storage, and disposal of hazardous waste. And it also has a framework for the management of non-hazardous solid waste too. TSCA provides EPA with authority on different chemical substances or mixtures. The picture is of a TSDF, or a treatment, storage, and disposal facility in Central California that EPA permits for PCB waste at this facility. So it's called Kettleman Hills facility. And this project took several years and was analyzed by several scientists at EPA, as well as the California Department of Toxic Substances Control. While groundwater wasn't expected to be impacted at this site, there was rigorous groundwater monitoring, modeling, and then quarterly reporting is required to ensure that the groundwater doesn't become. So ultimately, permitting may require groundwater modeling and mitigation measures, and EPA works closely with the permittee to ensure the highest level of safety for disposal of waste. So it's not quite the same as NEPA, but it goes through the baseline studies, the modeling, the site characterization, and the impacts, and followed by monitoring and mitigation. And that's really all that I have for you today. And I look forward to questions after David gives his presentation.
Great. Thanks very much, Sarah. And we're going to queue up the last presentation. I know we're running a little long here, but it's right that one. So I will move quickly through my slides. And in fact, Annalisa touched on a couple of the issues already. So you can go to the next slide. So I'm going to be talking about programs under the Safe Drinking Water Act, and in particular, two specific programs: the Underground Injection Control Program, or the UIC program, and then the Sole Source Aquifer program. So under the UIC program, the intent is to protect underground sources of drinking water. There are 6 different classes of UIC wells, and we typically require permits for deep injection wells. EPA implements the UIC program in the state of Arizona, although the state of Arizona has now developed their own UIC program, and they'll be submitting their program for EPA approval in the coming months. So you may hear about that, to take on the UIC program in Arizona. Nevada has responsibility for the UIC program, and then in California, we have what's called split primacy, where EPA has responsibility for some classes of UIC wells, and the state, as Annalisa pointed out, CalGEM has responsibility for others. Next slide. So these are just a depiction of the 6 different classes of UIC wells. All of these slides will be available, so you can look at this in more detail at your leisure, but I'm going to go to the next slide and highlight a few specific types of UIC wells that we regulate. The first type I'm going to talk about are Class 3 wells. These are wells for solution mining of minerals. So it involves injection of a fluid, sometimes an acidic solution, sometimes water, to dissolve the mineral and then extract it. EPA has issued Class 3 permits in Arizona for copper mining and for salt mining. And you may have heard of some of these permits. The Florence Copper permit is one. The Excelsior permit, those are both copper mine permits. And then salt mining in Arizona and borate mining in California. That's called the Fort Cady project. So this is one type of well that relates to mining and protection of groundwater. Next slide. Class 5 wells are shallow, typically shallow injection wells. So they include things like large capacity septic systems or industrial, stormwater drainage wells, that sort of thing. This is a depiction of some of the different types of Class 5 wells that we have. Next slide. In terms of our Class 5 wells on tribal lands, we've got actually these, I think this slide didn't get updated, but we've got about 1,800 Class 5 wells that we've inventoried in tribal lands on 74 different tribal nations. RCAC is a contractor who we use to do a lot of our field work. There's a shoe there indicating those are sort of our boots on the ground, and they can assist with things like mostly providing technical assistance and training, but they can also do things like operation and maintenance evaluations, and they can help to develop on-site wastewater management plans. Next slide. So class, is it still working? Yeah, okay. Class 6 wells, Annalisa mentioned them. These are the newest type of UIC well. These are injection wells for injection of CO2 into the deep subsurface. This typically happens into saline aquifers or depleted oil and gas reservoirs. It's a climate change mitigation strategy. You really have to have the right geology for carbon sequestration, geologic sequestration. There are many sites in California that have been identified that are good sites geologically for this practice. And then ADEQ, the Arizona Department of Environmental Quality, and the Navajo Nation actually have both expressed their interest in getting EPA's approval to run the Class 6 UIC program. So we'll be working with those entities, including the Navajo Nation, to see about developing a Class 6 program. Right now, EPA is the permitting authority for these wells. We've got 11 applications and 47 proposed injection wells. We are looking to make our first permit decision on geologic sequestration project possibly by the end of the year. That's a project in the Elk Hills oil field. Next slide. So just briefly, I want to mention the sole source aquifer protection program. Sole source aquifers are designated by EPA. The criteria are that the aquifer needs to supply at least 50% of the drinking water in the service area, and there cannot be an alternative source if that aquifer is contaminated. The process to designate a sole source aquifer is very time consuming and data intensive. It requires a lot of information, and basically once an aquifer is designated as a sole source aquifer, then any project that has federal funding needs to be reviewed by the EPA to ensure it won't be impacting that sole source aquifer. Next slide, and last slide. So here's just a map showing we've only designated 9 sole source aquifers in EPA Region 9, as you can see, and the dates of those designations are there. So the first one we did was in 1978, and then the last one was in 1996. So we haven't designated any sole source aquifers since 1996, in part because of the difficulty, how time consuming and data intensive that process is. But those are the 9 that we have in Region 9. So with that, I'm going to wrap up, and I know we're about at time, but maybe we take a few questions if people have questions. And yeah, looks like we have a question in the back.
Catherine Buchanan, North Coast Native Protectors Tribal Marine Collaborative, and my question is on, I have 2 questions actually, for protecting California's groundwater. I don't understand why quantity is not considered, especially when we have some of the driest mountains in the state of California, and groundwater aquifers know no boundaries, and jurisdictional boundaries should not be considered for water quantity measurements. We have, I believe, the Scott River that is now dry because it is groundwater fed and there's no groundwater to feed it. So when is the state of California going to consider protecting groundwater quantity in all the state of California and not just around the municipalities? My second question goes to the state of Arizona and their caveat for getting out of, it seems like, from the slides for protecting groundwater on tribal lands because they don't have jurisdiction over tribal lands. However, you do have jurisdiction over the groundwater that can travel onto tribal lands. So when are you going, are there a lot of groundwater monitoring wells around the outside of tribal properties? I mean, that doesn't make any sense to me. why tribal lands are excluded from being protected from contaminants.
So thank you for those questions. I think I'm going to have Annalisa and then Wayne go ahead and respond to those on the California question and then the question for Arizona.
Yeah,
Annalisa?
thank you. Great question and appreciate that nexus. The kind of programs that I had covered were really a lot around the water quality side because those are the programs that I oversee at the water boards. But we do have, and I should have touched on it and can definitely get you some more information. In California, we passed the Sustainable Groundwater Management Act, and it really is California getting its act together to kind of bring that nexus in of groundwater quality and quantity when it comes to groundwater resources. And so it's a collaborative effort. As Wayne had said, there's 2 agencies in Arizona, one for more of the volume and then the other one for the quality. In California, the Water Resources Control Board in my division really concentrates on the quality, but also recognizing that that quality is very much driven by quantity. And so we coordinate a lot with our sister agency, which is the Department of Water Resources, that primarily also kind of is tracking and implementing the Sustainable Groundwater Management Act and SGMA to collect the data and to start bringing in basins so that we can start regulating and monitoring groundwater quantity and its effects on groundwater quality.
Thanks, Annalisa. Wayne, did you want to?
Yeah, I would.
Respond?
I really appreciate the commenter's question, and I think what we're touching on is that groundwater is a shared resource, and it doesn't know boundaries. And so, I wholeheartly agree with the commenter's notion that these groundwaters should be protected, because they do not know any boundaries. The wells that are sampled for the groundwater monitoring program statewide are largely irrigation wells or water system wells that are kind of outside of the tribal areas on lands that are outside the tribal areas. So as far as are there wells that are around the tribal areas, the wells that are monitored as a part of the aquifer protection permit program are really specific to the facilities that they are permitted to monitor. So we really don't control where those wells go because we don't really control where the projects are going to end up. But when we permit a project, we require that they put in down gradient point of compliance wells so that the operator can, through monitoring, prove to us that groundwater is being protected and not contaminated. And I wholeheartedly agree that it's a shared resource. We're implementing the policies that we get from the legislature through our statutes and rules. And perhaps that's an area that we need to explore together on how do we better protect tribal lands from groundwater contamination that might be coming from offsite in our shared resource. So I think it's a great question.
So thanks for that, Wayne, and thanks for the questions. I think we've got another session who's going to be coming in shortly, so I'm going to wrap this up. But I want to thank my panelists, Annalisa Kihara, Wayne Harrison, and Sarah Samples for joining us. I want to thank Michael and Adam over on the controls there for pulling this off. Great job. And I want to thank all of you for joining us today. And I'll be around the rest of today and tomorrow if you have other questions that you want to ask, or I can connect you with any of our panelists. So thanks very much.